Hello, viewers. In today's session, we are going to discuss another important and conceptual problem from a range of functions. And in this class, we are going to discuss this function, that is y is equal to f of x is equal to tan inverse x minus 1 over x square. Right? So here we'll find out the range of this function using some important concepts. Right? So let us start. So now to get the range of this function, that is we have to find the interval for y, right? Because x is known as a domain and y is the range. So here we have to find the interval in which y belongs to. Right. So to proceed further, what we will do will take this quantity, that is x minus 1 over x square, is equal to t, where t is some new variable, right? So here we have x minus 1 over x square is equal to t. So let us solve this equation for x, right? So here we can see that the highest degree of x is 2. So we are going to get a quadratic equation. So let us solve this equation. X minus 1 is equal to x square t, and we have x square t minus x plus 1 is equal to 0, right? So this is a quadratic equation in x. So now let us compare this equation with the standard quadratic equation, that is ax square plus bx plus c is equal to 0. So our a is t, b is minus 1, and c is equal to 1, right? And let us find out the discriminant of this equation. So we have b square minus 4ac, and we have minus 1 square 4 times t times 1. So this is 1 minus 4 times t, right? So this is the discriminant of this quadratic equation. So now let us come to our original function. So here we have y is equal to tan inverse x minus 1 over x square. So x minus 1 over x square is assumed to be t. So we have tan inverse t, right? So from here we can write t is equal to tan of y. Right now, from this function, we can conclude that the domain of tan inverse theta function is the set of all real numbers, right? So the function f of theta, that is tan inverse theta, has the domain as the set of all real numbers, right? So theta belongs to the set of real numbers. Now here this x has to be a real number, right? So x has to be a real number. So therefore from the quadratic formula, we can see that x is given by minus b plus minus square root of d over 2a. Now if we substitute the value of b, d and a, then we have 1 plus minus square root of 1 minus 4 times t, and here we have 2 times t, right? So the values of x are given by this expression in terms of t. Now see, x belongs to the set of real numbers. So it means this x has to be a real number. So for x to be a real number, this quantity, that is square root of 1 minus 4t, plays an important role. So our d must be greater than or equal to 0, because the roots of this equation should be real. So for real roots, the condition is discriminant should be greater than or equal to 0. So for this, we must have 1 minus 4t greater than or equal to 0. So we have minus 4t greater than or equal to 0 minus 1 minus 4t. We have minus 1, multiplying both sides by minus 1, the direction of inequality get reversed. So we have 4t less than or equal to 1. So t is less than or equal to 1 over 4, right? So now our t is equal to tangent of y. So here we can write tan y less than or equal to 1 by 4. Right now, taking the tan inverse of both sides, we get tan inverse of tan y, and then here we have tan inverse of 1 over 4. So here these two get cancelled due to the concept of principal value branch, or in other words we can also say that the tan inverse function is an increasing function, right, for all values of x belonging to the set of real numbers, right? So when we take the tan inverse of both sides, the direction of the inequality doesn't change, it remains the same. Because of this reason, that is tan inverse x is an increasing function, the derivative of tan inverse x is 1 over 1 plus x square, and 1 over 1 plus x square is always greater than 0 for all values of x belonging to the set of real numbers. So from here we get y, and here we have tan inverse 1 over 4, right? So the value of y is always less than or equal to tan inverse 1 over 4, right? So the value of y, it belongs to the interval that is minus infinity to tan inverse 1 over 4, and here this value is included, right? So this is the interval to which this y belongs to. So viewers, the range of this function is given by this interval, that is minus infinity to tan inverse 1 over 4.